We want to find the slope of the secant line between 2 and 6, it says. Well, here's the thing. This is y equals mx plus b, so this is just going to be a line. And it's going to look like that. So the slope of any secant line on this is going to be part of the line. So that slope is just going to be -5 anywhere. So the slope equals -5. Also, the slope of a tangent line at 3. So at 3, wherever 3 is over here on this graph, the tangent line is going to be the line. This only works if it's linear. So the slope of the tangent line is also going to be -5. Now the equation of the line at x equals 3. The equation of the tangent line. Well, the tangent line is also going to be the line. So the equation of the tangent line is going to be y equals -5x plus 3. It's kind of a trick question. Not really a calculus question. Now, once we get to x squared, that's a calculus question. So we want to find the slope of the secant line, which is an average rate of change. So we have to do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And we have our x sub 1 and our x sub 2 already. So I'm going to set that up with the little slope template. And our x sub 2 is already given. That goes on the bottom left. That would be a 2. Our x sub 1 is already given. That goes on the bottom right. That would be a -1. So we have to be careful with our arithmetic. Now what we want to do is we want to plug this -2 into that original function. So I'm just going to plug in that 2 into the original function. So 2 parentheses 2 squared minus 3 parentheses 2 plus 1. So that value at x equals 2 is going to be 4. So I put a 4 on the top left. Now I want to plug in a -1. So you could retype it in or just back arrow and delete that 2 there and replace it with a -1. Don't forget we have to back arrow over to the other value, replace that with a -1. And that's going to give us a 7. So if you're afraid of your arithmetic, you could type this whole thing into the calculator, hit the fraction bar, 4 minus 7, down arrow, 2 minus -1, and the slope is going to be -1 between those. So the slope of the secant line is going to equal -1. That -1 has nothing to do with that x value, -1. All right, find the slope of the tangent line at x equals 2. So the slope of a tangent line, we want to take the derivative of the original function. So that derivative is going to be the power rule, 2 times 2, that's 4x, minus the power rule, that's net -3. And we're going to evaluate that at x equals 2, and that'll give us the slope at x equals 2. So let's see here. So we throw in the 2. So that would be 4 times 2 minus 3. That would be 8 minus 3 is 5. So the slope at 2 equals 5. Find the equation of the tangent line. Well, we already have the slope of the tangent line. And what we're going to need to do now is find out what the y value is. So I have an x value of 2. I need a y value. And we did that over here. We plugged in 2 here. So when I plugged in 2 to that equation, I got a 4. So the y value at 2 is going to be 4. And the slope we got over here by doing the derivative. So the slope equals 5. And now we're just going to do point slope form. Y minus y sub 1 equals m times x minus x sub 1. Y minus 4 equals 5 times x minus 2. And I think that's all they really want us to do. We don't have to simplify that or rewrite it in any other form. Slope of the secant line, again, this is a cubic, so the graph is going to look like that. So at -1 and 2, we'd find -1, we'd find 2. We're going to calculate the slope of the secant line connecting those 2 points. Now, I don't know. I'm just doing a sketch here. It might be going this way. It might be going downhill. It might be going straight across. So we have to evaluate this. So what we're going to do is we're going to set up the slope template. This is my x sub 1 and this is my x sub 2. So I'm going to put the 2 down here on the left, the -1 over here. We're going to plug that 2 into the original equation. So we're going to need to use the x box key. So parentheses 2, we're plugging in 2. And we're going to cube it by hitting the x box. Minus parentheses 2 again, squared. So at 2, it's 52. So on the top left, I need to put a 52. Now we're going to plug in a -1, so I'm just going to back arrow and change those 2's to a -1. So at -1, it's going to be -8. Hit my fraction button. 52 minus -8, down arrow, 2 minus -1, and that gives me 20. So my slope is going to equal 20 between -1 and 2. Find the slope of the tangent line at x equals 1. So I'm going to take the derivative of x cubed minus x squared. So that would be 3x squared minus 2x evaluated at that x equals 1 is going to generate the slope. So when I plug in 1, that's going to be 3 minus 2. So the slope equals 1. Now, for the next part, part C, they want us to find the equation of the tangent line at x equals 1. So let's see. I'm going to plug in 1 to the original to get the y value. And I already have my slope equals 1. So when I plug 1 in there, that's 1 cubed minus 1 squared, so that's 1, 0. When I plug in 1, so 1 cubed minus 1 squared, that's going to give us 1 minus 1, which is 0. So I have my point and my slope, y minus 0 equals 1 times x minus 1. I did simplify that one a little bit. Find the slope of the secant line between 3 and 4. So again, this is x sub 1, this is x sub 2, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to set up my cute little slope template for average rate of change. I already have the x sub 2, it goes on the bottom left. The x sub 1, it goes on the bottom right. We're going to plug a 4 in, so 4 minus 2, that's 2. 4 minus 5, that's -1. So that's going to generate a -2. I'm going to plug in the 3 now. 3 minus 2 is 1 over 3 minus 5, that's -2. So that would be -1/2. Ooh, I am definitely going to use the calculator on this one. So I'm going to hit my fraction button. -2 minus -0.5, down arrow, 4 minus 3. That's going to give me a slope of -3 over 2. Now they want me to find the slope of the tangent line at x equals 2. So I'm going to take the derivative of this and plug in 2. Now I don't want to take the derivative of a fraction. That would be quotient rule. So I'm going to use the derivative button on the calculator. So you want to be in normal mode. So mode 1, normal computational mode. And then you're going to hit shift and then this button here. And the derivative button will appear. I'm going to type in the fraction bar, then alpha red x minus 2, down arrow, alpha red x minus 5, evaluated at x value 2. Hit equals, and it'll give us the slope. So the slope is going to be -1/3. It's pretty ingenious. So slope equals -1/3. Now over here, they want to find the equation of the tangent line at x equals 2. So we already found the slope at x equals 2. So we have the x value of 2. Now we need to know what the y value is. We have the slope equals -1/3. So we're going to plug 2 into the equation over here. So 2 minus 2 is going to give us 0. 2 minus 5 will give us -3. So at 2, the y value is going to be 0. So y minus y sub 1 equals m, -1/3, times x minus x sub 1, which is 2. So y equals -1/3 times x minus 2. If you want to go back and test that process, you can find the slope of a cube at a point using the calculator. So they want us to find the slope of this cube at x equals 1. So you're going to hit shift, derivative. Again, it's shift, and then this button here will generate the derivative button. X cubed, so alpha red x cubed. I'm reworking number 3 again on the calculator. Minus alpha red x squared at x equals, they told us to do it at x equals 1. And the slope is 1. And notice, when we did it by hand, the slope was also 1. Number 5 is kind of wordy. If an object travels a distance of that, where s is in feet and t is in seconds, find the average velocity of the object within the first 10 seconds, instantaneous velocity at t equals 3. I can do the instantaneous velocity, but I can't do the average velocity. I don't know the formula for that one. So I think you might divide everything by 10. So I'm going to go to B. Instantaneous velocity. So is going to be x value 3. So I need to plug 3 in to get the y value. And then I'm going to take the derivative and plug 3 in to get the slope. So if we plug 3 into that, that'll be 2 parentheses 3 squared minus 5 parentheses 3 close parentheses plus 1. No fancy mode, just mode 1. So that's going to be 3 negative 5. Now if I want to find the slope at that point of 3, I'm going to do the derivative button. So shift derivative button. And we're going to type in 2 alpha red x squared minus 5 alpha red x plus 1 at x value 3. And it'll give us the derivative of 7, which is the slope. You could have done the power rule and then plugged in 3. It should have also given you 7. So y minus y sub 1 equals m times x minus x sub 1. And that's all you should need. Limit as x approaches 1 from the left. There's what x value 1 as I approach it from the left. Oops, from the left. This is the left side. This is the right side. As I approach it from the left, it's getting closer and closer to the y value 1. B, as it approaches 1 from the right. Approaching 1 from the right, there's the x value 1 that I'm getting close to. The y value that I get close to is 3. No sign, so that means from both sides. Now, notice, when I approach it from the left and the right, the 2 pencil points don't meet. That's called a jump discontinuity. That means the limit does not exist there. F of 1, I'm going to plug in a 1, and it's going to be non-existent. Open circle, open circle. DNE. Limit as x approaches. Looks to me like negative infinity. Negative infinity would be the left. So as x goes to the left, what does the y value go to? The y value gets lower and lower, so that's going to be negative infinity. As x approach, that's it for the graph 1. Graph 2. Find the limit as x approaches 2 from the left. As x approaches 2 from the left, the y value approaches 1. 2 from the right. As I approach 2 from the right, the y value approaches 1. As x approaches 2 from both sides. I know there's a hole there, but I'm getting close to 1 on both sides. So that there is going to be 1. F of 2 is the closed circle. The closed circle is at y value 0. Limit as x approaches negative infinity. Negative infinity is way over here. So as x approaches negative infinity, this thing keeps going down, I guess. So that's going to be negative infinity. As x approaches infinity. I don't know. I think that one might be a typo because it stops at like 0.5. If it keeps going down, it would be negative infinity. That one I'm going to leave blank. I don't know. Number 3 graph. As x approaches 3 from the left. So here's x value 3. As I approach it from the left, the y value I get close to is negative 3. X approaches 3 from the right. As I get closer and closer to 3 from the right, I stop there. What's the x value equal? The x value equals 3. Now the y value is what I'm looking for. The y value equals 0. 3 from the left and right, so that would be negative 3, and that would be 3. They do not equal one another. The answer is DNE, does not exist. F of 3 is where the closed circle is. That's going to be 0. The limit as x approaches negative infinity, it's going arriba, 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 arriba. So that would be positive infinity. as x approaches infinity. I suspect it's going down forever. That would be negative infinity. Limit as x approaches 0 from the left is 0. 0 from the right is 0. 0 from both sides is 0. F of 0 is 0. Limit as x approaches negative infinity. As x approaches negative infinity, y approaches infinity. Limit as x approaches infinity. So as x goes to the right, y goes down. Limit as x approaches 1 from the left, it approaches negative 2. 1 from the right, it approaches negative 2. 1, it approaches negative 2. F of 1, there's nothing there, it's a hole. dne. Limit as x approaches negative infinity, it goes upward, so that would be positive infinity. Limit as x approaches positive infinity, it goes upward. That would be positive infinity.
Limit as x approaches 1 from the left is going to be negative 2. Limit as x approaches 1 from the right, well, that's going to be negative 2 as well. Limit as x approaches negative infinity. Oh, I forgot the 1 here. As it approaches 1 is going to equal negative 2 also. And f of 1. So f of 1 is negative 2. F of negative infinity, as I get closer and closer to negative infinity, the line seems to go to 0. As I go to right forever, I think this is going to keep going up and up and up forever. So that one would be positive infinity. So limit as x approaches 1 from the left. So as I approach 1 from the left, it goes upwards forever. So that would be positive infinity. As it approaches 1 from the right, it goes down forever. That would be negative infinity. Since they don't equal one another, that would be dne when it's from the left and right. F of 1 is dne. There's no value there. As I approach the graph to the left, as I go to negative infinity, it goes to the horizontal asymptote of negative 2. As I go to the right, it approaches the other horizontal asymptote of negative 2 also. Number 8. Limit as x approaches 3 from the left. As I approach 3 from the left, it goes to negative 3. The y value is negative 3. 3 from the right, it goes to positive infinity. 3 from both sides is dne because negative 3 does not equal positive infinity. Limit does not exist. F of 3 is going to be that closed circle there, which in this case is negative 1. As I go to the left, negative infinity, it goes up. That's positive infinity. As I go to the right, it goes towards this horizontal asymptote, which is negative 1. Limit as x approaches 2 from the left, it goes up to positive infinity. 2 from the right, it goes up to positive infinity. Now, there's a lot of arguments over this one. It depends on what your teacher says. I believe they go at different rates, so it would be in dne, but some people say it is infinity and infinity, so it's going to also be infinity over here. F of 2 is dne because there's no value there. Limit as x goes to negative infinity, that would be to the left. It goes towards the horizontal asymptote of 0. As it goes to the right, that would be this other horizontal asymptote, and that would be negative 2. Limit as x approaches 0 from the left is going to be 0. As it approaches 0 from the right, that would also be 0. As it approaches 0 from both sides, it would be 0. F of 0 is 0, and that's the definition of continuity. Left limit, right limit, they're equal, and there's a value there. Limit as x approaches negative infinity. Well, this is bouncing up and down. It's oscillating. That's a trick question. So it's oscillating. So I'm going to say it's the average, 0. Same thing going to the right. It's oscillating. I'm going to say 0 as well. There's some rule on oscillation. Limit as x approaches 0 from the left is negative infinity. As it approaches 0 from the right, that's negative infinity. So 0 from both sides would be negative infinity. It goes down for all of them. f of 0 will be 0.5. Limit as x goes to the left, negative infinity, would be the horizontal asymptote of 1. To the right would be the horizontal asymptote of 1 as well. Limit as x approaches 0 from the left would be 1. 0 from the right would be 1. 0 from both sides would be 1. F of 0 would be 1. As I go to the left, so it goes whoop, 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 whoop. I'm going to say it's the average of 1 and negative 2. So when you add them up and divide by 2, that would give us negative 1 divided by 2. Negative 1/2 it would be. Negative 1/2. As x approaches infinity, you can see it's oscillating and getting closer and closer to 2. So that would be y value 2. So this one's kind of tricky. If you had the graph of y equals 3, at x value 4, the y value would be 3. Limit as x approaches negative 4 or 4x, that would be 4 times negative 4. That would equal negative 16. Plug in negative infinity, so that would be 5 times negative infinity plus 1. That would be negative infinity. As x approaches negative 1, that would be negative 1 squared minus 3 times negative 1 minus 1. So let's evaluate that one. That would be 1 plus 3 minus 1. That would equal 3. Plug in 3. So I'm going to hit the fraction button, and then I'm going to do 3 squared minus 3 times 3 minus 1 all over 3 plus 4. Negative 1/7. Plug it in 4. Going to hit the fraction bar. 4 squared minus 4 minus 12 over 4 squared minus 9 times 4 plus 20. Uh-oh. So that means we're probably going to get 0 over 0. So if we plug in 4 on the top, that would be 16 minus 4 minus 12. That's 0. And then we do it on the bottom, we get 0 over 0. So you can factor the top and factor the bottom, or you can do this thing called L'Hopital's rule, or H hat. So take the derivative of the top. The derivative of the top would be 2x minus 1 over the derivative of the bottom. 2x minus 9. Now we're going to plug in the 4. So that would be 8 minus 1 over 8 minus 9. That would equal 7 over negative 1. It would equal negative 7. It's called L'Hopital's rule. L'Hopital's rule.
So this is a limit at infinity. So when you plug in infinity, that would be 4 times infinity plus 1. So who cares about the 1? When you plug in 5 times infinity minus 2. So who cares about the 2? So that's going to be 4 infinity over 5 infinity. The infinities cancel out, so it's just going to be 4/5. It's also the rule for horizontal asymptotes if the degree of the top is the same as the degree of the bottom. So it would be 4 over 5. Infinity, this would be 1 over infinity minus 15. So who cares about the 15? And 1 over infinity actually equals 0. So when we plug in infinity, we're going to ignore those, and it would be 3 times infinity over 0.01 times infinity. And notice, these two infinities cancel out, so that would give us 3 over infinity, which would equal 0. Again, the rule for horizontal asymptotes, the degree of the top is smaller than the degree of the bottom, so it would be 0. As we approach negative infinity, so that would be negative infinity to the 8th. That would be positive infinity to the 8th. And this would be negative infinity to the 5th. So that would be 1,000 times negative infinity to the 5th. So that would give us negative infinity to the 3rd on top, which is negative infinity over 1,000. So who cares about that? Don't forget, we don't care about the 1. So since this is a negative infinity, it's going to go to negative infinity overall. This here, when we plug in negative 2, we get 16 minus 16, that's 0. Negative 2 plus 2, that's 0. So I try to be a little cute and say that spells oops. So you can either factor it or do L'Hopital's rule. Take the derivative of the top, which is 4x cubed. Put that over the derivative of the bottom, which is 1. Now we'll plug in the negative 2. So 4 times negative 2 cubed, that would be 4 times negative 8, and that equals, let's try it in the calculator. 4 times negative 2 cubed, I think 4 times negative 2 cubed, negative 32. I almost said negative 24. Negative 32. Negative 8, 4 times negative 8 is negative 32. Throw in infinity. So notice we have the degree of the top is the same as the degree of the bottom. So that's just going to be negative 3 over negative 6, or 1/2. Throw in a 5, that will give us 5 over 5 minus 5. Now 5 over 0, we're good with that. We're good with that. When it's divided by 0, that's the limit does not exist. It's only when it's 0 over 0 that we have to do other stuff. So we throw in a 3, so that would give us 3 minus 4, that's negative 1. And then 9 minus 9, that's another DNE. The limit does not exist. Plug in 0, that would be 1 over 0. The limit does not exist. Limit as x approaches 4 from the left. So this is to the right of 4. This is to the left of 4. So we're going to plug 4 in here. So that would be 3 times 4 minus 2. That's 12 minus 2. 12 minus 2 is 10. Limit as x approaches 4 from the right, so 4 is greater than or equal to 4. That would be on the right there. So I'll plug the 4 in there. That would be 16 minus 6. That would equal 10. So since they equal the same thing, the limit from both sides would also be 10. Don't have to do it. All right, so 4 over absolute value of 0 would equal 4 over 0. And that would be DNE. The limit does not exist. And notice this is a different equation than that one. So they wanted us to do that separate. Oh, that's number 18. That's why. I thought it was part of that. So let me go backwards to 17. Multi-part. So 0 from the left. Notice this is pointing to the left of 0. So 0 from the left. I put the 0 in there. And that would be DNE. 0 from the right. 0 from the right. That would also be DNE, but this one here is a little tricky. I want to use the calculator. So to the left of 0, that would be 2 over, something really close to 0 would be to the left of 0. So that would be negative 0.000001. Really close, but on the left of 0. Negative 2,000. So that would be actually negative infinity, not DNE. Negative infinity, not DNE. And then from the right, I'd put that negative 5 on top. So I'm going to back arrow and put negative 5 on top. And it's from the right, so that's not going to be negative 0.000. It would just be positive 0.00. A little to the right of 0. That's negative, so that goes to negative infinity. So that's going to be negative infinity. Trick question, and almost tricked me. We already did number 18 by accident. All right, number 19. They want me to plug in 3. So when I plug in 3 here, I get 0. When I plug in here, 3 here, I get 9 minus 18 plus. So that's 0 over 0. Again, you could factor it, or just do L'Hopital's rule, little h hat, and take the derivative of the top. That would be 3x squared over the derivative of the bottom. That would be 2x minus 6. Now when we plug in 3, 3 times 3 squared, that would be 27. Plug in 3 here, that would be 6 minus 6 over 0. 27 over 0 is D and E. So L'Hopital's rule is pretty cute. This one's a headache. So plug in 0, that would be 1/5 minus 1/5, that's 0, over 0. That spells oops. I don't want to take the derivative of the top. Maybe I do. Maybe I do. Because the derivative of the bottom would just be 1. The derivative of the top would get rid of that. So I'm really just taking the derivative of that, evaluated at 0. I can cheat on the calculator with that one. So I'm going to take the derivative of 1 over alpha red x plus 5, evaluated at 0. And that'll be my limit. Negative 0.04. That was cute. Let me type that in. Negative 0.04. And that gives me negative 1 over 25. Negative 1 over 25. All right, another infinity. So we're going to ignore the 3 and the negative 50. So that's going to be 4x over square root 2. And the square root of x squared is x. So when I plug in infinity, these are going to cancel out. So it's going to be 4 over root 2. 4 over root 2. She might not want you to leave it as a radical on the bottom. So that would be 2 root 2 if you evaluate it, if you rationalize it. So either that or 2 root 2 is your answer. She doesn't want us to do number 22. So when I plug in 0, I get root 2 minus root 2. That's 0 over 0. So that spells oops. So I'm going to do the L'Hopital's rule. So when I take the derivative of the bottom, it would just be 1. So that's going to be 1. The derivative of the top is going to get rid of that. So I just really need to take the derivative of that, evaluate it at 0. So again, I can dump that into the calculator. So that would be shift derivative key, in case you didn't see that again. Shift derivative key. We're going to type in square root alpha red x plus 2, evaluate it at 0. 0.35353333. Oy. I think that's 1 over square root of 2. I don't know. Let's write that down, and then I'm going to do it by hand. So that kicked out 0.35355. All right, the derivative of square root of x plus 2. I have a move for this one, so there's a lot of copying in calculus, so I copy that down. And the 2 that's hidden in there comes out, and then the derivative of the guts is 1. So then I plug in 0. That's actually 1 over 2 root 2. 1 over 2 root 2. So root 2 over 4. If I SD that, and notice it's that same decimal. So let me SD that. So it's root 2 over 4 is the answer. So your arithmetic will be your show all work. So it wants me to dump in the 6, but it tells me it can't equal 6. So I'm going to factor the top. So x times x equals x squared. 6 times 1 equals 6. The bigger one gets the negative. The smaller one is going to be a negative times a negative is a positive. You can mode 5-3 it. So notice now when I divide that by x minus 6, I can get rid of that. And then when I plug in the 6, that's going to give me 7. So the limit as x approaches 6 is 7. But it's not allowed to equal 6. It's approaching 6. So now they asked me to find the value for k such that the limit as x approaches 6 equals f of 6. So that's going to give me 3k plus 2 equals, and we already solved that to equal 7. So 7. And then we'll subtract 2, so 3k equals 5. So k would have to equal 5/3. Yay, take a derivative. The derivative of negative 12 is 0. The derivative of 7x is 7. The derivative of 7 minus 8x, the derivative of 7 is 0. The derivative of negative 8x is negative 8, so it's going to be negative 8. Power rule, 2 times 8 is 16x. The derivative of negative 3 is 0. 2 times negative 12 is negative 24x minus 4 plus 0. Well, I'm not afraid of those letters, so that's going to be 2a times x. The derivative of negative bx is just negative b. The derivative of negative ab, if negative ab are constants, that's 0. Just like the derivative of 4 is 0. So my derivative is 2ax minus b. Pi is a constant. The derivative of pi squared is 0. The derivative of negative 3 pi is 0. The derivative of 1 is 0. That was a trick question. So it's 0. Four times 12 is 48x cubed. 3 times negative 17. Three times negative 17 is negative 51. X squared. And the derivative of negative 1/2 x, if you rewrote it like that, would just be minus 1/2. So when I take this derivative and multiply that by 9/3, so 3 times 9 is 27 divided by 3 is 9x squared. 2 times 15 divided by 2 is negative 15x. And then 1 times 7/4 is plus 7/4. And the derivative of negative 4/11 is 0. So 9x squared minus 15x plus 7/4. I don't know. I've never seen one like this before. I want to distribute the negative 2/5. So that would be negative 6/5 x to the 5th plus 10. Plus 2x squared. And a negative times a negative, positive. So that's going to be plus 24 over 5. Take the derivative of this. That would give us negative 6x to the 4th, because that 5, when I multiply it, will simplify with that 5. 2 times 2, that would be plus 4x. And the derivative of that fraction, which is a constant, is just 0. I would rather not do quotient rules, so I'm going to rewrite this. I'm going to do algebra first. I'm going to rewrite this as 7x to the negative 3 minus 5x to the negative 1. And then I can do that if it's not like an expression over an expression. So negative 3 times 7 is negative 21x. Don't forget you subtract 1, so to the negative 4th. Negative 1 times negative 5 is positive 5x. You subtract 1 to the negative 2. Now we might be expected to rewrite it with positive exponents. So this would be negative 21 over x to the 4th plus 5 over x squared when you rewrite it with positive exponents. This one, they're trying to trick you into using the quotient rule. I would not use the quotient rule. Stay away from it as much as I can. So I would divide each of these out by 2x. And when we do that, notice this would be 13 halves. I'm going to write it over here. 13 halves x squared, because the x cubed and the x will simplify, minus 7 over 2x, because the x squared and the x will simplify, plus 1/2, because the x and the x will simplify. Now I'm going to take the derivative of this. So 2 times 13 halves would just give us 13x minus 7 halves, and the derivative of 1/2 is 0. What the hell? They want me to use the product rule. And again, I'm not going to fall for that. I'm just going to do a big, huge 3 by 12 punnet Maybe I should do the product rule. So it's going to be 11x cubed minus x squared plus 1. Yeah, I'm going to have to do a big punnet anyway when I simplify it, so I might as well do the punnet now. 2x to the 5th minus 8x cubed minus 7x minus 1. And now I have to do my arithmetic, CLT, and then take the derivative of each term. So 11 times 2 is 22, x to the 8th. 11 times negative 8 is negative 88, x to the 6th, negative 77, x to the 4th. You add the exponents when you multiply, minus 11x cubed. Negative 2x to the 7th, positive 8x to the 5th, positive 7x cubed. So we have some cubes, some like terms here. Plus x squared. I like multiplying by 1. It's like the closest thing to fun you'll do in my class. 2x to the 5th minus 8x cubed, 7x minus 1. Now we're going to seek and destroy and take the derivative. 22 x to the 8th, and we have a 7, only one 7. So that would be minus 2x to the 7th, x to the 6th. We only have one x to the 6th, minus 88 x to the 6th. 8 and 5, when we add those up, that's going to give us 10. Or 8 and 2, when we add those up, that's going to give us 10 x to the 5th. So these 3's line up. So 7 minus 8 minus 11. 7 minus 8 minus 11. That's negative 12 x cubed. Oh, I missed the 77x to the 4th. I missed that one. I'm going to rewrite negative 12x cubed over here and put my 77, negative 77x to the 4th there. I missed it. X cubed, x squared, 7x minus 1. Take the derivative, 8 times 22, 176. X to the 7th, minus 14, x to the 6th, 6 times 88, negative 528, x to the 5th, plus 50, x to the 4th, 4 times negative 77, 308, minus 308, x to the 3rd, 3 times 12 is negative 36, x squared, plus 2x plus 7. All right, they got me. I have to do quotient rule. There's a song, low, D, high, minus high, D, low. Draw the line and square the low. Low, D, high, minus high, D, low. Draw the line and square the low. I have a high value. I have a low value. The derivative of the high value, the D high, is going to equal 2x plus 5. The D low, the derivative of the low value, is going to be 5. So I'm going to set up my template. Low, D high, minus high, D low, draw the line, and square the low. So my low is 5x minus 6. My D high is 2x plus 5. Minus high, my high is this trinomial, x squared plus 5x minus 2. D low is just 5. Low D high minus high D low. Draw the line, throw the low back in the bottom, 5x minus 6. And, oops, hopefully squared. Hopefully they let us keep that as our answer. I'm going to do low D high minus high D low. I have a high value. I have a low value. The derivative of the high is 0. The derivative of the low is 6x. So low, d high minus high, d low, draw the line, and square below. The low is 3x squared minus 5. Low, d high, the high is 0, so this is going to go to 0. Minus high, d low, which is 6x. And then throw that down in the bottom, 3x squared minus 5. So this one we would be expected to simplify, but it's not that big of a deal. That would be negative 6x on top. And the bottom would be 3x squared minus 5 squared. You probably would not have to FOIL that out. So I think that's a cube root of x. So I'm going to rewrite that as x to the 1/3. And that's a 5th root of x. So minus x to the 1/5. But because it was on the bottom, I bring it up and it would be negative 1/5. And then I take the derivative of this. I don't have a shortcut for this one. We're just going to do it the way we're supposed to. So power rule, 1/3 x, and then 1/3 minus 1. So 1 over 3 minus 1 would give us negative 2/3. So to the negative 2/3. And then power rule, negative 1/5 times negative 1 would give us plus 1/5 x. And then negative 1/5 minus 1. So let's do that one. Negative 1 over 5 minus 1 would give us negative 6/5. And there's our derivative if they want us to rewrite it. So this would be 1 over 3 cube root of x squared plus 1 over 5 5th root of x to the 6th. And they might want us to rewrite this one as 1 over 5 x 5th root of x. That's a tough one. So they might let you leave it like this, or they'll have this one and this second one, because that's x to the 5th times x, and x to the 5th can come out. I'm going to change them all to rational exponents, so that's x to the 1/4 times x to the 1/2 plus 3. Distribute that, so 1/4 plus 1/2. 1 divided by 4 plus 0.5 equals 3/4. So when I do this times this, that's going to give us x to the 3/4 plus 3x to the 1/4. And now let's just do the power rule. And then convert it back to a radical. So that's going to be 3/4 x, and then 3/4 minus 1. So 3/4 minus 4/4 would be negative 1/4 to the negative 1/4. 1/4 times 3 would be plus 3/4 x, and then 1/4 minus 4/4 would be negative 3/4. So I guess we'll rewrite that as radicals. I can do it. I'll do it underneath. So that's my derivative. Now I'm going to do the arithmetic. This would be 3 over 4x to the 1/4, or 4th root of x, plus 3 over 4, and this would be the 4th root of x cubed. And nothing simplifies there, so we're going to leave it like that. We can do quotient rule, or we can rewrite this as x to the 1/2 and then divide it out. So x squared over x to the 0.5 minus 2x to the 1st over x to the 0.5 minus 3 over x to the 0.5. So 2 minus 0.5 would be x to the 1.5. 1 minus 0.5 would be minus 2x to the 0.5. And this one I'll rewrite as a negative exponent, negative 3x to the negative 0.5. And now let's just do the power rule. So 1.5 x to the 1.5 minus 1 would be 0.5. 0.5 times negative 2 would be negative 1. X, 0.5 minus 1 would be negative 0.5. Negative 0.5 times negative 3 would be negative 1.5, or positive, I'm sorry, plus 3 times 0.5. 3 times 0.5 would be 3 halves, SD, negative 1.5, plus 1.5, x to the negative 1.5. Rewrite that. I'm just going to rewrite it underneath. So that would be 3 halves square root x minus 1 over square root x plus 3 over 2 x to the 3 halves, x to the 3 halves on the bottom, so that would be the square root of x cubed, and they might rewrite that as 3 over 2x root x. They might rewrite that one. All right, number 20 is a table. So they want me to find the derivative of this. So I'm going to take the derivative normally. So I'm going to have a high, I have a low. My d high is h prime of x. My d low is 2g prime of x. And low d high, low 2g of x, low d high times h prime of x minus high h of x, d low, which would be 2g prime of x. Draw the line and square the low, so 2g of x squared. So that's going to be 4. That's going to be 4 there. So we have to be careful. They want me to find f prime of 5. So I'm going to plug a 5 in wherever there's an x. So g of 5 is 2. 2 times 2 would be 4. H prime of 5 would be 3. Minus h of 5 is negative 0.5, so that's going to be plus 0.5, times g prime of 5. G prime of 5 is 2, times 2 is 4, all over g of 5. G of 5 is 2. 2 times 2 is 4. 4 squared is 16. (12) plus 2 over 16. Let it do the work. 7/8. So this one here is going to equal 7/8. So I'm going to do, I can distribute it, and that would give me g squared, and I'm still going to have to do product rule, so I'm just going to do product rule. The derivative of g prime of x is, or g of x is g prime of x. The derivative of this is going to be g prime of x plus h prime of x, which is, what's nice now is g of x, so I'm going to set up another template. G of 5 is 2. And then g prime of 5 is 8. And then g of 5 is 2. Plus h of 5 is negative 0.5. So 2 minus 0.5. G prime of 5 is 8 plus H prime of 5 is negative 1/2, so minus 0.5. Oh, H prime of 5 is 3. So again, I'm going to keep my little crisscross here. I'm going to simplify it again. So that's going to give me 2, 8, 1.5, and 11. Crisscross applesauce, that would give us 22, plus 8 times 1.5, 12. 22 plus 12 is going to be 34. So the 3 and the negative 3 cancel out. The negative x and the positive x cancel out. The negative 2x squared and the 2x squared cancels out. So that's going to leave us with a 4hx plus 2h squared plus h sobre h. And then the h will cancel out from each term. So that would give us 4x plus 2h plus 1. And that's the limit as h approaches 0 of this. So we're going to put a 0 in there. And that would give us 4x plus 1. Or if we didn't want to follow the limit definition rule, we could have just taken the derivative of this. It would be 4x plus 1. So she said she wanted the whole thing. I don't think if it's a multiple choice, you'll have to do that. You'll just have to find the derivative. Tangent line, so at the point negative 2, 1, so they give us that. All we need to do is plug in the negative 2 to the derivative. So the derivative of this is going to be x plus 3, and you plug in negative 2. So that would give us the slope equals 1. You could also use the calculator. All right, we can use the derivative button on the calculator for it. And we're going to evaluate the derivative at negative 2. So you're going to hit shift in the derivative button and 0.5 alpha red x squared plus 3 alpha red x plus 3 evaluated at negative 2. And the slope is 1. So I have a coordinate, negative 2, comma, negative 1, and my slope is 1. Y minus y sub 1, which would be plus 1 here, equals m, which is 1 times x minus x sub 2, which would be plus 2 now. And sketch both curves, so I'm supposed to graph the tangent line and the curve. All right, that's no biggie. So this is going to be y equals 1x plus 2, x plus 2 minus 1, so that's y equals x plus 1. I begin it 1, and I go down 1 over 1, or up 1 over 1, up 1 over 1, up 1 over 1. So I'm going to graph that straight line there. This goes through 0, 1, 2, 3. I'm going to mode 5, 3, the equation. Find my intercepts and my vertex, mode 5, 3. So I'm going to type in 0.5 equals 3 equals 3 equals. Ooh, so that's at negative 1.27, negative 1.27, so that's an x-intercept there. and negative 4.7. Negative 1, 2, 3, 4.7. That's another x-intercept. There's my y-intercept. Y-intercept is 3. Now I'm going to get my vertex, negative 3 and negative 1.5. Negative 1, 2, 3, negative 1.5. And its tangent at negative 2, negative 1. It's just going to touch right there and then go up. That's a tough problem. Find the equation of the tangent line to this and parallel to that. So the slope of this is going to be the opposite of A over B. So that would be negative 2 over 1, or equals negative 2. So I'm going to take the derivative of this and set it equal to negative 2. So 2x minus 4 equals negative 2. 2x equals 2. X equals 1. So I have x equals 1. So at x equals 1, I have to find is where the tangent point is. So I'm going to take that 1 and plug it in to find the y value. So that would be 1 minus 4 minus 7. That would be negative 10. Take the derivative at 1, so that would be 2x minus 4. 2x minus 4. Evaluated at x equals 1, so the slope, again, would equal negative 2, because it's parallel to that. So y minus y sub 1 equals negative 2 times x minus 1. Oh, they want decimals, so calculator active. Derivative of f of 2 plus g of 2. So that's going to be f prime of 2 plus g prime of 2. F prime of 2 is 7. G prime of 2 is negative 4. So that's going to equal 3. This one we have to do product rule. So f prime of 4, g prime of 4. So f of 4 is 9. G of 4 is negative 3. F prime of 4 is pi over 2. Wasn't expecting that. G prime of 4 is pi. Crisscross applesauce, that's 9 pi plus negative 3 pi over 2. I might type that into my calculator. 9 pi minus 3 pi over 2. 9 pi minus 3 pi over 2, 15 pi over 2. I have a high, I have a low. My D high is going to be f prime of x. My D low is going to be g prime of x. I'm going to fill in my values now. F of 9 is 4. G of 9 is 2. F prime of 9 is negative 3. G prime of 9 is pi over 2. Low, D high, minus high, D low. Draw the line and square the low. The low is 2, so 2 squared is 4. That will give us negative 6 minus 2 pi over 4. They're all even numbers, so that would give us negative 3 minus pi over 2. You might want to, I wouldn't type that in. It would probably just give us a decimal. We're going to do product rule for this one. So x squared, the derivative is 2x, g prime of x. So x squared when x equals 4, that's going to give us 16. That's going to give us 2 times 4, 8. G of 4 was -3. G prime of 4 was pi. Crisscross applesauce, that would be 16 pi plus -24 or just minus 24. Horizontal tangent, you take the derivative and set it equal to 0. No calculator on this one because you have to set the answer equal to 0. So that would be 3x squared minus 3x minus 6. Now when you set that equal to 0, you can mode 5-3 it. Mode 5-3, we're going to type that in. And when we set that equal to 0, there'll be 2 places. There'll be 2 places. So let's see here. 3 equals... -3 equals, -6 equals, so 2 and -1. So at x equals 2 and x equals -1 are going to be where my horizontals are. Write the equation of the normal line perpendicular to the graph at x equals 0. Find the horizontal, find the points of horizontal. So this one's done, x equals 2 and -1. Now for this one, write the equation of the normal line perpendicular to the graph at x equals 0. So up here I have to plug in 0 to get the y value, and that would be 0, 10. Now I have to take the derivative, which I already did, and plug in 0 to the derivative. So when I plug in that 0 to the derivative, I get a slope of -6. But perpendicular slope would not be -6 over 1. The perpendicular slope, the normal slope, would be 1/6. So y minus 10 equals 1/6 times x minus 0. Parallel to the x-axis. So find the x and y values of all points. So the x-axis is horizontal, so it's going to be at these values. So doing question C, we need to use these values from question A, from part A. So x cubed, we should know, looks like this. And -1 is going to be over here, and 2 is going to be here. And they want to know what the y value is. So when I plug -1 in, it'll give me the max value, or relative max. And when I plug in 2, it'll give me the relative min value. So I have to plug in -1 to that equation. I'm going to use the calculator, mode 1, and type it in. So parentheses, -1, close parentheses, cubed, minus 1.5 parentheses, -1, close parentheses, squared, minus 6, parentheses, -1, plus 10. So 27 over 2, or 13.5. So down here I have a coordinate of -1, comma 13.5. And the other one is going to be 2, comma, and we'll figure out what that is. I'm going to back arrow and plug in 2 now. And that's 0. So 2, 0. So there's your answers for that one.